glance, you might think this question is asking you to graph these polynomial functions over here. Negative 5x to the 8th minus 7x to the 7th, and so on. That would be a really heavy-duty graphing job, but it's much simpler than that. If you remember what end behavior is, and I've drawn a few of these over here on the right side. If you remember what end behavior is, it matters what the exponent, the highest exponent is of the polynomial. It's called the power function. If you have a polynomial that is an x squared, it's going to have some kind of a shape looking like what I drew here with a parabola. If you have a polynomial that is an x cubed, it's going to look a little bit like this little danger noodle thing here that goes down on one side and up on the other. Now there's variations on these things. There is perhaps a cubic function that looks like this, right? Where you see there's some turning points in there, but it still is going down on the left and up on the right. Or you could imagine flipping it around. Maybe that's a negative x cubed, in which case it might look like this, right? Up on the left, down on the right. But in either case, it's generally doing this odd behavior where it's going up on one side, down on the other. Now, let's go back and re-examine what this question is asking. It's saying, is there a global maximum or minimum for each function? Now, remember what a global maximum means. It means an absolute maximum, something that is clearly the highest point of that function. Or if we're talking about a minimum, the lowest point anywhere for that function. And if I highlight on this graph all the global maximums for you, there's one for the x squared, it's a minimum. There's one for the x to the 4th, it's a minimum. But the x to the 3rd and the x to the 5th do not have global maxima because they go down on one side and up on the other. Regardless of how many hoops or swings or whatever's going on in this graph, there is no point that is the lowest or the highest because in those directions you have arrows, and those arrows go to infinity. So what this means is global maximum, and I can make a general rule here, global max or min only exist for even functions. And again, we're talking about polynomials. So what I'm saying here doesn't go for other types of functions like rational functions, for example. But for polynomials, you simply just look at the exponent at the leading term and say, is that even or odd? And it might have all sorts of other things in it, like, see this x cubed over here? Sure, that had, let me put this in a non-committal color. That had a local max and a local min, but that's not what we're talking about. We're talking about the absolute max and min. Okay, so now come over into these polynomials and take a look at its degree, its highest power. This one is an 8, okay, or a 4, or a 6. And those would be, yes, there is a global max or min. Yes, yes, and yes. Whereas the ones that have an odd power, right, that's going to be x cubed or x to the 7th. Those are hard no. There is no global max or min because in those cases, you have the arrow approaching infinity or negative infinity on either end.